Okay, what I'm going to do today is first, I'm going to talk about homework 4. Homework 4 should be really simple. You probably, I think you can get homework 4 done right now within the next 15 minutes. I will, let me post my code also so you can take a look at that. I'm going to put it under, hold on, GitHub. Let me create a directory again. Let me actually just include in the last one I used, which is 1114. Yes. So I will add a file, upload file. And this is the program I'm going to use to talk about today. So this is what I'm going to show you is really helping you, but also try to learn a little bit deeper about C++. That's always good. Let me see. It must be under program, must be under homework 4. And this is test program. Okay, good. Okay, this program I just added is called test MI, which stands for multiple inheritance underscore f2022 CPP. Okay, so let me actually show you what the code looks like. Why this is giving me like this? Maybe it's the other window. Okay, here. So I'm going to show you a program and tell you what I'm going to do. So this part is, okay, so first thing we're going to go over homework 4, and then I'm going to get back to a midterm. And then we're going to, after I give you a midterm, then we have snack, then we go into homework 3. Okay, that's our plan today. But I want to first tell you this program. I hope you can see this, or you can download from the GitHub. This one I'm actually include the virtual inheritance, but now I want to show you a PowerPoint slide, which actually also I think is very helpful for us to understand what's going on. Multiple inheritance is slide number 7. Yes, number 7 is good. So this part is what we call virtual inheritance. You can see that relationship is account, employee, student, and work study. And this is what we call memory layout. Each of this is a byte. This is a byte, is a pointer. This is a byte because is attribute, which is a byte. And then there is another pointer, a byte, a byte, a byte. Okay, so homework number 4 is really try to ask you to learn or to refresh your knowledge about pointer, and so you will be able to know how to print out the address of each of this, and also seeing how the casting in C++, particularly in the multi-inheritance or virtual inheritance situation, when you do the casting, you can see that when I do the casting, it's actually changed the address. So how do you actually know that the address you print out is actually correct? If you print out the address to the work study object, it should be, I'm talking about the situation for virtual inheritance only. So the address of work study, and if you're casting as an employee star over the same pointer, the address print out should be the same. If those two are the same, you know you're right. And the variable for the employee should be actually 8 more hexadecimal. Okay, if this is 8, then this should be B0, because that's the +8 as a hexadecimal. So you can look at the difference between the address and the address of the variable, because why there is a gap? Because there is a pointer over here. I'm going to show you what this pointer really is. All right. And then if you actually casting the same object with a student star, means you casting to a student object then essentially your address should be 16 more. Okay, 8, 8, 16. If this two should be the same, this one is 16 more, then you actually get the right result. And then from this address, if you cast into account, you actually add another 24 or hexadecimal 18. Okay, this is a 24. So that's the way to actually look at the number. It's really to seeing that in C, when you casting a pointer, no matter how you cast, the value never change. But in C++, they actually have the concept of multiple inheritance. So when you cast, it's actually going to change. All right. So let me actually show you some program over here to see what's going on. All right, so you can see that I actually using virtual inheritance. In fact, I'm using the same test program for both, but I'm just changing whether I'm doing virtual inheritance or multiple inheritance. So you can see that what I did first is that I have an object called work study objws, and I actually have a pointer of that address, of that object, which is objws_ptr. So objws_ptr is essentially, I'm talking about is the first address. Is the first address over here. Okay. All right, so then I'm actually going to show you this very simple example. Now you can see that I actually casting with a student. So if I casting this with a student, it should be +8 of the first pointer. So let me actually do this to show you the difference. Let me do 3 line, then you can see the. So the first pointer I'm going to print out is without casting. Okay, without casting, print out the address, and then with casting of student star. And then I'm actually casting the student and pointing to the S1, which is the variable under student, and then look at the address. And then let's see what's the result of the first 3. Don't worry about the warning because I actually use some depreciation function. So if you look at the first 3, the first one is the pointer, the work study, which is a 90. And then the second one is A0, that's student. Let's look at the slide. What's the difference between these two? Between these two, 8 plus 8 is 16, right? So that's why the address is actually separated by 16 from 90 to A0 hexadecimal. So if you know their difference by 16 hexadecimal, you know the answer is correct in your program. And now we look at next one. The next one is A8. So the difference between the second address and the third address is exactly 8 byte, which is shown in this picture as well, because where is the S1? S1 is here. And because they separate by 8 byte, it's because there is a virtual table pointer over here. And what's the virtual table pointer is trying to help us? Is actually trying to help us to link to account. So the whole idea of a virtual inheritance is that you allow multiple objects to share the same ancestor, not like multiple inheritance. Multiple inheritance, you have 2 copies of the ancestor. But here, you only have 1 copy of ancestor, everybody share. So you need to have a pointer from here to somehow get you here. Okay, so here is some extra information you need to get. So that's why this 2, the number 2 and number 3, is separated by 8 byte. Okay, so this is the second one. This is the third one. You see that one is A0, one is A8. They're separate. Okay, so essentially what I'm showing you is how do you actually print 1 casting and 1 variable. What's the address? That's the 3 line. You can actually download. And I want you to do this for all 4 classes. all the casting for employee, for account, for work study, and then basically the relationship. How do you check your answer? The relationship should be reflected exactly, looks like this for virtual inheritance. And the relationship should show in this picture, which is for multiple inheritance. Okay. Try to do that when we start to do this party mode, and then you have a question, I can help you, or you can help each other. That's okay. All right. All right. So I want to talk a little bit about this guy, because this is a mystery. This is there and is actually being occupying our memory. What exactly this one is working on? How does it work? So that's what I want to do. By the way, this part is trying to deepening your knowledge about C++. It's nothing to do with homework 4. Okay, this part is just for your learning. But I think it's important for you to learn. All right, so how do I actually get to that part? Okay, my knowledge basically tell me this one itself is a pointer. This one itself is a pointer. It's pointing to somewhere, which is then pointing back or give me some answer. And so it is, as a programmer, it's always good for us to learn exactly where it's leading to is coming back, right? So the first thing I want to do is that, okay, if this is a pointer, I want to know where it is pointing to. So how do I actually do that? Let me actually show you how I did this. This part is a little bit messy. By the way, it's because the C++ is constrained. Okay, so let me actually say, well, let me ask you first the question. How do you actually print out the content? We're here, right? Student, work study. How do I actually print the content of this 8 byte? How do I actually do that? How do I actually print the content? What?
If I have a pointer, use the star and then whatever.
Use a star, right? Okay. So the thing is that, let me actually tell you what I tried to do. Let me actually see whether this works. So this is the pointer, right? I'm using this at the beginning. Okay. This is a pointer. I want to actually use what? I want to use star, right? Star to this pointer. I use a star to that pointer, which is the student. And then because I want to print it as a pointer, so I will casting as a generic pointer void star. Okay, that's the way our first thought. How do you actually see the content of the pointer? You actually have to do this. I star on that particular object pointer, which is after the casting. I hope you can see that. In the pointer, you always have to use some imagination to see what the star is doing what. And then I casting with a pointer void star. Let's see how the compiler is going to like this or not. Okay, the compiler actually gave me an arrow. And what the arrow said, he said, I cannot cast from student to type void star, which makes sense. So what is a star to a student pointer is a student, right? So student is an object, and I want to cast it to a pointer. It actually doesn't like it, because when I say star, it will treat it as a object, which is a student. So this failed. In fact, I actually try a few different ways for me to print the content. It's not that trivial. I'm not saying that what I'm going to show you is the only way to do it, but this is based on my experience, try different way. Eventually, I have to do this. Let me tell you that how I did this. This is also show you how you can manipulate pointer in C++. Okay, so this doesn't work. So I just keep it here. This didn't work. Okay, so now let me actually tell you what I did. What I did is very, a bit, I would say a bit unconventional or bizarre about what I'm doing. So what I did is I actually take the pointer. I take the pointer, which is the address. And guess what I did? I actually used sprintf, which is a function causing that depreciated message. So I actually print the address as a string. Okay, I print the address as a string. You can actually print it as an integer as well, I believe, but here I'm just decide to use a string to look at the string case. So basically I print the address as a string. So I store that address in the buffer format in a buffer string, buffer array. And so now I convert it to a string. Then look at what I actually have. I declare another pointer, which is I call it XYZ PTR. I just pick a random name. It might not be the most beautiful name, by the way, but it's a pointer. It's a generic pointer. It's a void star. And then I do scanf. I scan that buff, and then I look at %p, means that I want to treat that string as a pointer. So you can see that I print the pointer to a string, and then I actually loaded the pointer back from the string format to the address format. So at this point, XYZ is what? XYZ pointer is actually receive the content of that address of the virtual table pointer. So this is one way to do it. I'm not saying this is the most beautiful way, but this is the way to do it. And then what I did is that I take that content, because I know it's a pointer. Now I want to see how that pointer is pointing to, and then I just put a star over here. And then again, casting pointer, because I know it's probably a pointer. So let me actually repeat what I did. If you know this 4 lines of code, you probably know how to manipulate a pointer in any kind of context in C++. Because in C++, they check very rigorously, not like your C program. So I first print the address to a string, and then I read it back to a pointer, and then I dereference that pointer I just got. Okay, so this 4 line, what's the result? Now you can see that the 4th line, the address is over here. So essentially what I'm saying is that virtual pointer under student star, the address is actually pointing to this address. This address is actually what we call the virtual table address area. It's not static, depending on how your system works. Okay, so then that's, to me, that still looks like a pointer. So guess what I did next? This is basically a hacking, okay? Let's look at the program, and I know it's this 3 line, this 4 line basically gave me to that virtual table. It's still an address. So what should I do? Don't worry, I do that again. You see, I play exactly the same thing, but I actually, this time, because it's already generic pointer, I don't need to do the sprintf or scanf. I directly using this 2 line, try to casting this address, and then I try to dereference that reference. So I did this time, I call it ABC. It's still not work. And then I go the 3rd time, go to DEF. I actually dereference it 3 times. Let me actually show you what the result I got. If you run the program, you can see that this is the first dereference, meaning that that's the pointer that's pointing to from this pointer. That's the first time. And then that one will lead me to another address, which is this one. That's the second dereference, the second layer. And then from the second layer, I actually pointing to another area, which I'm printing the result, which is a 0x18. What is a hexadecimal 18? What is the value of hexadecimal 1/8? 24, right? Hexadecimal 1/8 is equivalent to decimal 24. And what's that 24? It's actually from here to here. So essentially, they're using this reference pointer. They keep the value, which is 24. In the virtual table, it's not giving you a physical address about where this is, but instead is actually giving you what should be the offset between the student object all the way to account star. And that's how you can actually casting from over here to skip 24 by. That's actually being stored in the virtual table. So you can imagine, this is actually not a compiler time. It's actually have to be runtime. At the runtime, when you do casting, it needs to dereference the pointer 3 times. Dereference 3 times. And eventually from this pointer, you can actually casting to this account. So that's the complexity about virtual inheritance when you actually need to deal with this. Okay. Any questions? So this is more advanced. By the way, a lot of even graduate students, they never bother to look at the address. But I want to tell you the power is in your hand. You can always play that. Yeah.
Why do you cast to avoid the pointer after you dereference again?
Oh, the reason that's a very good question. The reason I do this, let me show people the example like this way, right? I actually dereference it. Okay, I dereference this and then I do a void star. The difference is that if I don't have this void star, what do you think it will be the type of this line? Okay. No, the type is going to be long, right? This one is I actually casting as long star. So if I dereference a long star, then it will be long. So you're going to print a decimal format because it's treated as an integer, a long integer. But I want to print that as decimal. That's why I want to cast it. So essentially, how you cast the CL interface is going to detect what's the data type I should interpret the output. That's why I put a void star. So let's actually change this. Let's actually do this. If I do this, if I remove this, you can see here, the first one is hexadecimal. The second one is decimal. 24, because it's interpreted. Okay, it's a minor detail, but it's important to learn that cout will detect what's the data type you actually at the result of all the casting, what it is, and then it will use whatever that data type to decide. By the way, C++ is a strong type language. It's much stronger than C. C++ is kind of very similar to Java in this perspective. Okay, good question. Any other question? Okay, so just want to remind you that this is the first part is really just for you to finish homework for, and so you know how to actually print the address. The second part I want to say is advanced, pretty advanced knowledge for C++ programmer, especially when you want to deal with the runtime internal data structure about where your virtual table really is. I mean, but I think it's good. I feel you guys are might be able to leverage this knowledge to some very interesting things. Okay. All right, I'm going to stop recording because I'm going to